Okay, so now let's consider the complex conjugate situation for Euler Cauchy equation. So the Euler Cauchy equation is this. X square this one. X square y prime plus y double prime a y ax y prime plus b is equal to 0. Plus by is equal to 0. Okay, and for this we said that the characteristic equation can be represented by like this: a minus 1 m plus b is equal to 0. M square plus a minus 1 m b plus is equal to 0. So of course this is a quadratic equation, and suppose that the roots of this quadratic equation are complex conjugate. So in terms of the quadratic formula, the roots are minus a minus 1 over 2 plus minus this value. What is that? It is a minus 1 square minus 4b. Okay, or in another word, if you simplify it, so it will be 1 minus a by 2 plus minus, and I think we simplified it in the previous case, was this situation. Okay, 1 by 4 a1 minus a square root 1 by 4 1 minus a square minus b. Yes. Okay, so this for these roots have to be complex conjugate. We can represent these complex conjugate roots as something like this. If we say 1 minus a by 2 is alpha, and the term in this figure as say beta or gamma. Okay, maybe we can say gamma, and then represent the I as the imaginary number. So we can represent these roots as alpha plus minus gamma I. Okay, so where gamma is equal to 1 by 4 square root of this minus b, negative of that. Okay, so where gamma will be equal to b minus 1 by 4 1 minus a square root. Okay, and then we will left with this I. So these are the roots. So in fact these are the complex conjugate roots, but these are also the distinct roots. So we can say that the solution for the distinct root can also apply for these roots. So what is the solution for the roots in the case of Euler Cauchy equation is c1 x power m1 plus c2 x power m2. So where m1 are alpha plus gamma I or alpha minus gamma I. So in this case we have these roots, but we can see that these roots are, this solution is fine. Okay, alpha plus gamma I or alpha minus gamma I is an acceptable solution, and it's mathematically a correct solution. However, this solution is in the form of the complex numbers. There is a way to to represent this solution in the form of real numbers, okay, as well. So therefore we have to transform this solution into real numbers. So transform from complex to real numbers. Okay, so this transformation from complex to real can be obtained by Euler's equation. So what is the Euler's equation? Euler's equation says that e to the power omega I, omega is some real number, I is you know, that is the imaginary number, so it is equal to cosine of omega plus iota, is we call I sometimes as iota sine, okay, omega. Okay, so we can use this for this purpose. So in this case we have m1 and m2 as respectively alpha and gamma I respectively. So we can represent alpha and we can represent it these roots. So for example, let me take the first one. Okay, so y is equal to this first solution and then the second solution. Just for the time being, not consider the constants of integration. So let's, the first solution will be y1 is equal to x power m1. So x power m1 can be represented as x power alpha plus gamma I. Okay, so alpha plus gamma I. So we can also write it like this: alpha, x power alpha into x power gamma I. So now look at this alpha power x power gamma I. Okay, so it is something similar to this over here, but not exactly. What we need to do further is we can write it like x power alpha, and x we can write as e log, okay, e log of gamma I. Okay, e log of gamma I. So if we write it like e to the log of gamma I, so it will be simply gamma I. So it will not be x power gamma I. So I can write it like something like this: e power e log x to the gamma I. So here we have x e power log x power gamma I. So which is basically same as x power gamma I, but we can further write it like this: x power alpha. We can write from the log x power gamma I, we can take gamma I outside of the log. Okay, so it will be e power gamma I log of x, gamma I log of x. So gamma I log of x, or in other words, we can also write it like this: x power alpha into e power, so gamma log of x, gamma log of x into I. So now we can see that we can now compare this term e power gamma log of x I with omega log of x. So it means that what we have done is we have replaced omega with the gamma log x. So we can write it like this: x power alpha in terms of this. We can replace it in terms of this. So it will be cosine of gamma log of x. Okay, cosine of gamma log of x plus iota sine of gamma log of x. Okay, so we have got this expression for y1. So for y2 we can similarly get an expression, because for y2 it will be x power m2, and x power m2 will be alpha minus gamma I. The alpha minus gamma I will be x power alpha into x power minus gamma I, and since it will be minus gamma I, so it will be x power alpha into e power log, okay, x power minus gamma I, or in the same way x power alpha, then it will be e power minus gamma I log of x, or in same way it will be x power alpha minus gamma I log of x I, right? So it will be x power alpha cosine of minus gamma log of x plus iota sine of minus gamma log of x. So now we know that x power alpha cosine of minus gamma log of x is same as cosine of gamma log of x, and sine minus gamma log of x is actually minus sine gamma log of x. So here it will be, the sign will be change. It will be minus iota sine gamma log of x. Okay, so we have two equations now, y1 and y2. Okay, so these y1 and y2, these are the equations. So if we add these two equations, so this means y1 and plus y2, and then divide by 2, so then you can very easily see that the sine term will cancel out, and what we will get is x power alpha into cosine of gamma log x. Okay, and then if we subtract y1 minus y2 and then divide by 2i, okay, yeah, then we will divide by 2i, then we will cosine term will cancel out, so we will get x power alpha sine of gamma log of x. So now what we can see over here is that since y1 and y2 are the solutions of the original equation, so therefore for example, if y1 and y2 are solutions of the given equation, then from the principle of superposition, because y1 and y2 are the independent solutions, the linear combination will be also a solution. So then y1 plus y2 over 2 is equal to y1 over 2 plus y2 over 2 is also a solution of the equation. Similarly, y1 minus y2 over 2 is also a solution. So it means that both x power alpha sine gamma log x, x power alpha sine gamma log x are the solutions. Okay, but in this case you can see that these are the real solutions. So it means that we can write the general solution as some constant a times x power alpha cosine of gamma log of x. So this is one argument for cosine x, and then b times sine of gamma log of x. Okay. Yes, and this alpha is actually common with both terms. So x power alpha, so b times x power alpha will be also here. So we will see one example of this application of this equation in the next video clip.